Hey there, welcome to today's video, where we're going to dive into a fascinating problem in programming. The problem we're exploring today revolves around the implementation of a queue data structure and a specific message handling scenario. So picture this. We have a queue data structure created using a function called queueMaker. When we send the object a message like enqueue with an operand, say A gets pushed into the queue. But here's where the twist comes in. We also want to handle the message enqueueList with a list operand to add all items in the list to the queue. The burning question on our minds is, why not just use the append function to modify the queue instead? Now, let's delve into the solution to this peculiar problem. The key lies in understanding the complexities that arise when considering the use of the append function in this context. Take, for instance, the enqueueList twice function defined with two consecutive calls to enqueueList with the same list operand L. This code snippet highlights the potential dangers of using append to implement queue operations. The scenario painted here illustrates how utilizing append could lead to destructive modifications within the queue, ultimately creating traps for unwary programmers. It becomes crucial to avoid such risks by opting for safer and more reliable approaches in implementing queue functionalities, steering clear of potential pitfalls that may arise from misguided use of certain functions. Wrapping up our exploration of this problem and its solution, we've uncovered the intricacies involved in efficiently handling queue operations while steering clear of potential pitfalls, by understanding the shortcomings of using append and the risks it poses to the integrity of the data structure. We can make informed decisions when implementing queue functionalities. With that said, we've reached the end of today's video. If you found this discussion insightful, don't forget to subscribe, like, and leave a comment below. Remember, in the world of programming, it's always better to be safe than sorry.